All right, welcome everyone to the Capitalized Theater. We are going to start the next panel conversation. Topic for today is the remarkable journey to IP. And I have a number of distinguished panelists here. These guys have actually worked together on a pretty significant project, and so have a lot that they want to share with you about this transition towards IP as being a fundamental networking technology within the broadcast industry. Let me introduce the panelists to you. All right, we're going to start. We're going to go down the line here. We have Ian Cobb, who is a senior IT systems architect with Alpha. Oh, wow. You brought a cheering section. That's great. I love it. Next down the line is Aron Kennedy. He is the chief broadcast engineer for Arizona Cardinals, Insignia Events, and State Farm Stadium. Next is John Myatt, the CTO of the Video Products Group at Imagine Communications. Yeah. And finally, last but not least, we have Yousuf Khan, who is the VP of Technical Marketing from Cisco. And I don't know what you guys paid for that, but it was worth it. That's pretty great. As I said, the topic that we're going to go through today here is how this IP networking fabric is actually being used to implement projects all around the industry. The project I was mentioning that these guys worked on together is actually the project at State Farm Stadium with the Arizona Cardinals. A lot of great learnings from that project, and I think these guys are going to share some of the details with you as we go through the panel today. But John, I wanted to start with you. Obviously the journey towards IP started a number of years ago. You did a lot of the early work on the SMPTE 2110 standard. I believe you were the drafting chair of ST 2110 at SMPTE. Where do you see the state of the industry right now? Where are people at with IP? How is it being used? And what's kind of the current state of the art as far as what people are doing with IP-based networking technology for video?
Oh, thanks for such an easy question, Steve. So, 10 years ago when we started down this journey of SMPTE 2110, it was very much, getting ahead of it with standards, because to enable a marketplace, there need to be technical standards that everybody follows. And one of the early decisions we made was we're going to use normal IT networks and use them in the normal way. Now, this paid a lot of benefits because here we are all these years later. SMPTE 2110 was published in 2017, seems like forever ago. And as you'd predict, the IT networks have now, have the speeds and feeds to do incredible things. I mean, it's a very standard thing to get a switch with 132 gig ports or 32 100 gig ports or 32 400 gig ports even. It's like a standard item. You order it, you want two, you get two. So it's really encouraging to see that now SMPTE 2110 has become kind of the basis of design for any new project of any real size. And as we watch the market evolve, every product you see on the show floor, there's a 2110 variation of it. Sometimes that's the only variation there is for it. So it's really moved from a, let's try this. Can this work? Hey, this does work. This only works for big projects. Now this really works out for almost every project. So it's great to see that story arc to where this is now a mainstream technology that is the basis of design for most new projects.
Yousuf, working at Cisco, obviously, you guys do projects of all scale, right? I mean, from small projects that you probably do day in and day out to the largest networking projects that have ever been done. As you guys have been more involved in bringing that kind of IP networking fabric into the media industry, what are some of the key challenges that you have seen your customers face, and how have you handled those? What are the things that Cisco has learned, and what are the things that you guys believe are fundamental in terms of making sure that these IP transition projects are working?
No, thank you for the question. You're absolutely right. And I think I just want to tee off from what was said earlier is the basis, choosing IP transport network as the basis has paid its dividend, because IP we have been deploying from a Cisco perspective for the last 35 years in a wide variety of applications and a wide variety of use cases. As a result, we are battle-hardened solution that can cater to many, many different use cases. And broadcast media is also one of the use cases, and the challenges are to a large degree very similar, and some of them are very unique also to the broadcast media also. Depending on who the customer is and what the project is and what the context of the project is, the challenge can be different. I take a couple of examples from my memory in terms of the projects that we did is, for example, there was a university that we were working in Texas that wanted to connect different venues so that they can share the signals between them. And they realized that their existing SDI infrastructure doesn't have the capacity to bring all the signals together. And they didn't have the luxury of changing the cabling plan or build a new infrastructure that's going to add to the cost of that project immensely. So that's why they chose IP, and they realized that with moving to IP, which has the ability to carry multiple signals on a single wire, not only they can connect all those venues together with the existing capacity, but also they can share the signals across different users, right? Such as team recordings, such as video playbacks, such as talent monitors, and they had the capability to do so. So that, for example, I mean, that was the challenge, was existing capacity, and they wanted to use existing infrastructure, but they wanted to scale and wanted to share and bring all these signals into one single venue or share across multiple venues. I have one more example, I mean, where a customer was moving into a new facility, and they were building a brand new multi-story facility. At the same time, they were going and migrating from high definition signals to ultra high definition signals on 4K. So they wanted increased capacity. They needed to build multiple control rooms across multiple floors also. And so they not only looking for more scalability and capacity, but they were also looking for operational ease of use. They wanted to make sure that it is easy to create, deploy, and manage their networks. It is also easy to carry signals, high definition, ultra high definition, and 4K, and also future-proof their network for 8K signals also. And that is one of the reasons they chose IP technology, because it helped them address all those technologies.
So we have scale, we have flexibility, and we also have ease of operations. All of those things are benefits that you see in this move towards IP and ST2110. I'm going to ask the other two members of the panel here, what would you guys add to that list?
I think one of the major factors that is really helpful is you also reduce typically you reduce the amount of devices in the signal chain. If you think of a traditional baseband system, you'll have all these different conversion cards. You'll have a lot of these different individual devices performing different roles in the signal chain. Whereas on an IP-based network, you can either virtualize that processing infrastructure, or you can reduce the amount of points of failure you have in your overall air chain on your system. And you can also increase the density of of signals and processing power more so than you ever were able to before. So, density and also, increased resilience.
Yeah, that's actually another really great thing to add to that list. Aron, you guys did a big project. I mean, that stadium in and of itself is a very large project. What did you learn in that project, and how do you feel about using IP technology at this point in time to build a project of that scale?
Well, thanks for having me, by the way. So I was actually thrown into the project after it was commissioned.
Yeah.
Right. And with the previous team I was with, we were learning about the 2110, and my personal feeling is that everything's going to go in that direction. It just will. And copper's expensive, as they say, and density and flexibility is the key. There's budget things to consider from my side of the fence, and we look at what can we do now, how can you remain open to future scalability, flexibility. So we keep saying that up here, flexibility, scalability, and that's certainly the name of the game from where I sit for sure. When we host Cardinals games, it's pretty much the same thing every time, right? Once we get into the season and we kind of know what the Cardinals game is going to be, it's going to be more or less the same thing every time.
Yeah.
But we have the Final Four come in at State Farm Stadium just a couple weeks ago, and we don't really know what they want. It does take months of planning to get there, but your system has to remain flexible in order to accommodate what the producer wants. right? And that can go from a Final Four. In a couple weeks, we have a Feld Entertainment Monster Jam, which is not near as big, completely different asks from them. So it's really got to remain flexible to do all of those things.
And how do you see 2110 giving you that flexibility? What are some of the things that you're seeing as you operationalize that system?
Well, that's a good question. I mean, I said flexibility and just having that ability to.
Well, I mean, when you did the Final Four, but we were able to expand the system in 20 minutes by lighting up a couple more 100 gig ports, and we added another 64 channels of I/O to the system.
Thank you, Ian.
In a 20-minute session. And so being able to do that and turn those things around really, really quickly, I think, is what provides the flexibility.
Yeah. Does that answer your question?
No, I think that's actually a great example. And thanks.
I'm just an engineer.
Thanks for deferring to the expert there. But I think those are exactly the kinds of things we're looking for.
We've seen this with customers around the world that, nothing is ever the same from day to day in television anymore. It used to be you could engineer a facility and then build it and then operate it for 10 years.
Yeah.
And now it's like you engineer a facility while you're building it, and then it's up and going doing the show that you're doing today. And then 3 weeks later, a producer says, I want this. I want that. I need this. And you don't have the technical constraints anymore to say, well, my router ports are all full and too bad for you. Now it's like, we can do that. We can do that. And IP enables you to say yes in a lot of environments where you used to not be able to do it.
You're absolutely right. And I think while we are on the topic of flexibility, having the right transport protocol, having the right switch or router, which is not on the solution can scale to, as you mentioned, that 32 ports of 100 gig or 32 ports of 400 gig or 64 ports of 800 gig. We have the flexibility in the solution, but also build the network, tear down the network, change the network. It is very, very essential to have the automation in the system built in so that we can react to the changing requirements that the producers are throwing at us in this area. At the same time, we want to make sure that we do it in a more secure way, right? So that there is no risk to the environment, no risk to the network. So scalability along with flexibility, scalability along with security is extremely important, right?
I'll add one thing is redundancy for us is obviously very important. You can't fail in these events. You just can't fail. So having that redundancy, which has to do, in my opinion, with scalability and flexibility, it's all kind of the same thing. And you can just stack switches, and they all talk to one another. If one goes down, it doesn't happen too often. You'd hope not. But if it does, you can fail over. And you can't quite say the same thing with baseband routers back in the day.
Well, I think another thing with the redundancy is that you're able to achieve full end-to-end redundancy at a significantly lower cost than you would have previously in the baseband world. To do a similar approach to dash out, it would end up probably costing you a lot more than because nowadays it's built into almost every 2110 device, and you just need more switching infrastructure. Whereas in the baseband world, it would require a lot more heavy metal in order to pull that off.
I want to come back to that question of cost in a second, but before we go to that, so a lot of advantages, right? Scalability, flexibility, redundancy, reliability, all the things you guys are talking about here. But still, this is a different way of doing things, right? Moving towards 2110 and moving to IP and working with a different set of vendors. There are some people that look at that and they have a little bit of hesitancy towards that. They don't necessarily want to embrace that change. What would you say to people that are trying to make a decision about whether they should move down the path of going towards IP? And how do you get them to bridge past what's comfortable and move into something that has all of the advantages that you guys have been mentioning?
I'll take that really quick. With my previous team, we were considering the next phase of the control room, and it's going to be a rip and replace control room. And our thinking was, well, that control room has to kind of exist and be scalable and flexible for 10 to 15 years, whatever that time frame is. And if you don't jump in now, you're going to be outdated in the next couple of years. That's what my personal feeling is about that.
Yeah, I see the same kind of thing that you buy a 3 gig router, great, you can do 1080p. But someone's going to come along and say, hey, we're doing UHD. I don't know if UHD is going to take off this year or next year, but in the planning horizon of most of these stadiums, most of these venues, it's a real consideration, whether it's a design criteria on the first day or a got to be able to support it when it comes. It's one of those two things. And so, again, it's the moving to a fabric that's got more than enough capacity. In the old days, SDI was like the best thing you could do on coax, and we were the leaders of all that. But now in IP, the largest broadcast facility built is still in the medium to small range compared to the sizes of switches that Cisco and other people have.
No, you're absolutely right. I mean, as I was mentioning that for us, 800 gig is a reality today, and I know that it is gaining momentum into the enterprise world, but the amount of bandwidth that we can fit into one rack unit switch or router is immense, right? And the beautiful thing about IP is that it can scale up or down based on your requirements. Yes. And we do it in such a way, thanks to the standard body work that you have driven, is the workflow of the broadcasting industry is not changed, right? And that's where the integration comes into the different broadcast system. We have preserved the workflow, but we have made sure that we can future-proof the network for future needs, and we can go up and down as the requirements change.
Yeah. Ian, this is what you do day in and day out, right? You help guide people through this transition. So as a systems integrator, how do you work with the customer to move forward from SDI into IP? And what role do you see hybrid playing kind of in that transition?
Well, I think there's a lot of, there's a lot of hybrid solutions that we deploy every day. We've just completed recently some primarily baseband systems that have 2110 components. There's certain parts of the infrastructure that, it was silly to not do them in 2110. So we did those in 2110, even though the customer desired a baseband system. So there's a lot of hybrid models. There's also, people that want to, have a 2110 core, but need to provide a whole bunch of IP gateways at the truck dock to bring in other producers, other trucks. And a lot of it just kind of starts with a relationship and a relationship with the customer, and then working with them on identifying their needs and sharing our expertise that we've built up over the years, and finding a solution that's mutually successful for all parties.
So follow-up question on that in terms of that expertise. You guys were the integrator for the Cardinal Stadium, right?
We were not the initial integrator. We took over custody of the system after the initial integration. And I've been working closely with Aron for the past 2 years now. And we haven't really had any problems. The system's very successful.
Anything from that you share as kind of words of wisdom?
Words of wisdom, when you're setting up a system, you always want to make sure, you put in your due diligence and your planning. Working everything out on paper first makes the installation process go a lot easier. And then also just having a good documentation set helps everybody else that's involved with the system, understand how everything works. And so making sure you put the effort in on all that stuff up front is really, really important.
Yeah, that's good advice in general, I think.
So like design then build.
Well, you're still designing it as you're building it too.
This is the
try to get
order.
at least 80% of it up ahead of time.
Yeah. So Yousuf, I want to circle back to something that you touched on a couple of minutes ago, which is this kind of integration between what you guys do in the IP space and where there's a lot of experience that has come in from IT, right, from the kind of IT industry and the general IP use cases, and how we're using this in the broadcast space. So what do customers need to do to be successful in doing those kinds of integrations? And are there lessons that you've learned from coming into the broadcast space that you think would be valuable?
See, Cisco has been in the IP world or routing world or switching world for almost like 35 years now. And you can imagine that being the pioneer in the industry, we have to develop a lot of these technologies and invent a lot of these protocols and technologies. We have done that. We brought it to the market, but we have always a very, very strong commitment to the standard-based bodies. Because even if we are developing something, we would like to take it to the standard-based bodies and then work with them. And as soon as the standard is ratified, start shipping those implementation. And similarly, a lot of a technology that already existed in different enterprise world, different domains, For example, I mentioned that we are multicast hardened because we work in high frequency trading environment. We are latency sensitive because we work into exchange trading environment as well as high frequency environment. So we had all these technology building blocks that we were there, and we brought it to the broadcast world because we understood that here are the requirements. So first we worked on the SMPTE 2110 standard to make sure that all that expertise is baked into the standard. But also, I mean, we, along with you guys in the Imagine side, are the leaders in cross-vendor integrations. And we wanted to make sure that in order for this to succeed, it has to be a broader ecosystem of vendors that can work and integrate and interoperate with each other. So that's why from the very get-go, that intention was very clear, is that bring this to the standard body, make sure it is successful. And the second, I mean, unlike any other vertical that we always work in Cisco, we identify the top 1, 2, 3 partners that we need to develop integration with. And similarly, in the broadcasting, working with Imagine was one of our very top priorities so that we can integrate our solution with your broadcast control system, right? And this is how we did it, is that we expose our APIs to the Magellan control system so that we can enable a consistent and end-to-end seamless bandwidth management system, right? So that we can deploy IP networks end-to-end while without changing the flow of the broadcast, right? Because it was extremely important for us that customers can continue to deploy the same workflow that they are used to it, and we don't change that. We enable them, but we don't disrupt them. And this way, there is always a single source of truth from the broadcast control system that defines what the intent of the network is going to be. And if there is any change in the environment, that gets seamlessly communicated to the network all towards the endpoint. So that was very clear intention on our part to make sure that we give tools to the broadcast industry to deploy state-of-the-art end-to-end IP networks.
So the fact that you guys really helped embrace the workflows that already existed in the broadcasting industry, I think was key to the way that the standards got developed and the way they've been adopted. But John, I think from your side, it was more about using the IP fabric and the IT knowledge and really bringing that to the broadcast industry without having to modify what companies like Cisco had built as the fundamental platforms. Can you talk a little bit about why that was so important?
Oh yeah, it's very important to realize. In television, we believe that the television industry is extremely large and extremely important, and that's true. But if you look at, say, R&D spend across all of the different providers in the television industry, traditionally, versus the IT industry that supports, all of the, that drives, say, Cisco, it's a very different economy, right? So it became very clear that for this marketplace to succeed, all of the standards for television had to use the IT fabrics the way that they're designed. If we couldn't go down a path that said, oh, well, this will all be great if only the switches had some magical special feature, because that's just not how the economy of scale works. For television to prosper the way that we now see happening, it was vital that we get on the curve with everybody else, and that we use the same products, the same way, the same switches, the same technology stack that's used in high-speed trading and banking and large-scale data centers. And it's played out that way. So SMPTE 2110 succeeds because it uses normal multicast and IGMP and PIM and all of its various extensions in the same way that fin trading uses them, in the same way that large-scale data centers use them. So that way we can use the same scale-out products and same scale-out technologies that are used in every other industry.
Yeah. So let me ask our other two panelists here, the fact that everything was built on top of that standard IT infrastructure, what advantages did that bring to you from a design point of view and from an operations point of view, especially as it pertains to talent, right? Are you finding that you have a broader base of engineers and talent that you can draw on just because these things are built more on kind of an open IT infrastructure?
I think in general, yes, but it's a little bit questionable because in order for the entire solution to be successful, it does require some kind of broadcast knowledge, understanding kind of the needs of the video system itself. But at a basic level, all the technologies are the same. If you can configure a router port to use, PIM and back it on OSPF and all other stuff, if you can do that in the high frequency trading industry, you can do that in the broadcast industry just as easily and be just as successful. There's just a couple other, kind of requirements and areas of focus that are just a little different between those different industries.
What I'll say to that is, growing up in this industry and 20 years as an engineer for stadiums, when I first looked at it, it is a little, nerve-wracking to get into that IP space, right? Actually, I had somebody tell me just last night, who had been with a team for a lot longer than that. He said, "I like to see a video at the end of a cable." I thought that was a pretty funny saying.
Yeah.
And to me, I think it's just inevitable. Like, just come on, let's go. Because in a short amount of time, and it's accelerated probably tremendously in the last 5 years. You guys will know better than I do, but it's just inevitable that it will go that way. And so, as an engineer trying to learn, coming from an old school way of doing it and trying to learn the new one, all these tools now are being made to see the signal at the end of the cable, so to speak. Now you're just seeing it in a stream, right?
And I would almost like to argue against that kind of stigma, right? Where I can't see the video in the cable.
I agree.
Depending on how it's implemented, right? If you have auto discovery, you're not just hooking up to a static NMOS RDS. If you're doing auto discovery, you have DHCP set up for your devices. You can achieve that same functionality that you used to be able to achieve before by plugging the cable into your scope.
Yeah,
and so
I
it
totally
really just
agree
depends on implementation.
All right. So, the other place that this conversation about using standard COTS IT gear always leads us to is the question of cost. So where do you think the industry is at right now in terms of what kind of projects are well suited to this IT and IP infrastructure from a cost perspective? Is it just really big broadcast centers? Is it just really big stadiums? Or are we actually at a place now where the cost to implement smaller projects actually makes sense to do it in IP? And Yousuf, I think I'm going to start that one with you.
Absolutely. Right. I think we mentioned in the beginning that for sure the greenfield environment makes sense to start with IP. But even for the brownfield existing environments, as industry is moving from high definition to ultra high definition, it makes sense to adopt IP because we can give you more capacity over your existing infrastructure. I mentioned that for sure the greenfield makes sense. If you look at the biggest sporting event all around yourself, whether it is Olympics, whether it is NFL, whether it is NBA, whether it is FIFA World Cup, IP broadcast is playing part in it, right? Even smaller universities, colleges, they are adapting this technology and adopting this technology because they don't want to bear the cost of revamping their infrastructure. And IP gives them a way to migrate from high definition to ultra high definition using their existing infrastructure. In other words, not increasing the cost, but increasing the capacity, right? And that is a great testament to the IP technology also, right?
Yep. And as we look at the history, when we started this in 2013, table stakes, sort of a high-end switch had ports that were 10 gigabits. And, so quaint now, but that was like a $50,000 switch had ports at 10 gig.
Only one device, only one thing went in that one.
Yeah, and each one did one, yeah. And so just over the years, Gordon Moore was right, and he was right at every level of the chain, that with mass adoption, if you stay on the standard profile of the industry, the costs drop and the features double over a period of, 18 to 24 months over and over again. So what was 10 gig 10 years ago is 100 gig now, and is increasingly 400 gig. It was 100 gig last year. So that curve just propagates into the cost of everything in a really positive way. It allows us to build projects now where, if you spec a 256 square SDI router with MUX DMUX on every port, or if you build it out of 2110 gateways, which one pencils out better? The 2110 one does now.
Yeah. That's become the price point. Hey, I'm getting the wrap up sign, so I want to just close with one last question that I'm going to give each one of you a chance to answer. And that is, in a short summary, if somebody was looking at a new project that they wanted to start today, what would you tell them is the number one reason to do it in IP with 2110? Ian, you get to go first.
I think it's the best way to preserve your investment. there's no other way to future-proof your investment than to invest in a well-hardened IP infrastructure to put your organization on the right foundation for the future.
Aron?
For me, it's redundancy. Honestly, it feels like redundancy throughout, and you can't fail at an event at all.
I think having a full-scale IP infrastructure allows you as a broadcast engineering organization to go from being the department of no, we can't really do that, to the department of yes, we can.
Well, the disadvantage of being last, because all the good points are already mentioned, but I'll say a couple of things, right, which are not mentioned, which is network visibility, and the other one is automation, right? And the solution that we have built around IP brings these two attributes to it, right? Network visibility is extremely important so that we can give you visibility into each and every multicast flow within your environment, how much bandwidth it is taking, right? We also give you complete automation so that you can, with a click of few buttons, deploy your network, right? Change your network, increase the capacity, decommission endpoints. So IP has a full suite of solutions available.
Well, hey, I want to thank all of our panelists today. You guys were really generous with your time and sharing some of the wisdom that you have. If anybody has questions after the panel, these guys are going to stick around for a couple of minutes to answer any questions you may have, but let's give a hand to these panelists.